Hello, and welcome to Project 3.4, Pin Change Interrupt. This project calls for us to read the rotary encoder provided to us from Mr. Darcy to display a number through the 4511 onto the 7-segment display. This number can increment
up or decrease
through 0 through 9. And when you reset the nano, it should start on the number 5. The user can enter their password by first rotating the rotary encoder to their preferred digit, there we go, I've just selected 4 right there. For their next digit, all they have to do is move it to their next number, which can also be the same number, and press select, or push down on the rotary encoder. And then to make their third and final digit, they repeat the process of selecting down on the rotary encoder. As you can see, my safe has opened up. If the user, say, enters the first digit wrong, or even the second digit wrong, they can press the reset button, which is a debounced button, and once they do that, they can enter the correct password, and there you go, the safe opens. The wiring for this circuit is quite simple. From this side, you can see the port C, which the low nibble is going straight into the 4511 inputs. This feeds a binary number that is then decoded by the 4511 into a decimal number that can be displayed on the 7-segment display. 2 pins above the low nibble of port C, still on port C, is the bicolor LED, which can switch from red to green, as you've seen. And on the other side of the circuit, you can see port D, which has the 2 external interrupts, as well as port D pins 4 and 5, which are holding the pin change interrupts of the rotary encoder. Additionally, we have a debounced button using a 10K and 1K ohm resistors, as well as a 1 microfarad capacitor. To begin, we should start in the void setup of my code. First, we declare a serial monitor setup. Then I set my guess attempts to 0. Then I set up the external interrupts, the display setup, as well as showing the digit 5, which is mandatory in the procedure of the project. Then what I'm doing here is I'm finding the new data on port D. So I'm reading the entire port D, and then I am using some bit shifting techniques and masking techniques to find only pin A. I'm saving this to a new variable called last A. The rest of this is for declaring the pin change interrupts. The void loop of my function is the next thing we should be looking at. I made sure to keep it most of my code out of the loop function. So what I have at the top is if triggered. If triggered represents if there is a pin change interrupt. If so, it is reading the data on port D, and then it is reading what digit it should show from port D and displaying that on the 7-segment display. So data kind of represents port D, and then read data is generating a digit, which is then sent to the show digit. External interrupt 0, this is tied to the rotary encoder's push button. So as you can see, I have a guessed function representing that the user has pressed his or her button and has guessed, made a guess. Below that, I have if the password is equal to guess. Obviously, this means that the user has inputted the right password, and I set my LED to green. And then finally, I'm using an if-or statement where either the reset button was pressed, the clear answer button or the clear guess button, or guess attempts has reached over 3, meaning that the user has inputted over 3 attempts. In that case, both the guess and the guess attempts would be set to 0. And then within this loop function, I'm always setting the LED red.